myself Hena Shah, Assistant Professor at LG Institutes of Engineering and Technology. So today we are going to discuss few more topics of multiple integrals. So let us begin with the first topic, that is triple integrals in rectangular coordinates. Okay. So the triple integral of a continuous function f of x, y, z over a region V can be evaluated by three successive integrations. So the triple integral of f of x, y, z over the region V is denoted by triple integral over V f of x, y, z dv. So this is the notation for triple integrals. Okay. So now let us solve one example. So we have to evaluate triple integral from 0 to 2, 1 to z, 0 to yz, x, yz, dx, dy, dz. So now let us begin with the solution. Okay. So this is your question given, right? So firstly we will evaluate this with respect to x, keeping y and z as constant, right? So keep this as constant. So integration 0 to 2, integration 1 to z, yz, dy, dz will remain as it is. And our integration of x will be what? X square by 2. And your limits are 0 to yz. Okay, now we will put the limit in place of x, right? So what we will get? Y square, z square. We will take out this 1 upon 2 outside. Now if you put 0 in place of x, then the whole term will become 0, right? Now we'll simplify this. So what we will get? Y cube, z cube. Okay. Now we'll integrate this with respect to y. So what will keep constant? We will keep z as constant. So we'll keep this z cube as it is and integrate this y cube from 1 to z. Okay. So on integrating, what we will get? Integration of y cube will be y raised to 4 upon 4 and your limits are 1 to z. Okay. So now let us put the limit in place of y and take this 4 outside. So what we will get? 1 upon 8 integration 0 to 2 z cube. If you put z, what you will get? Z raised to 4 minus, if you put the lower limit 1, then you will get 1 and dz, right? Now we will simplify this. So what we will get? Z raised to 7 minus z cube and integrate this with respect to z. Okay. So 1 upon 8 will remain as it is. Integration of z raised to 7 will be what? Z raised to 8 upon 8 minus integration of z cube will be z raised to 4 upon 4 and your limits are 0 to 2. Okay. So now let us substitute the limit. Now if you put 2, here we will get 32 minus 4 and if you put 0, the total answer will be 0, right? So on simplifying this, finally you will get your answer of the triple integral as what? 7 upon 2. Okay. So now let us go to our next topic, that is triple integrals in cylindrical coordinates. Okay. So cylindrical coordinates r, theta and z are used to evaluate the integral in the regions which are bounded by the cylinders along z-axis, planes through z-axis and planes perpendicular to z-axis. Okay. So the relations between the Cartesian coordinates x, y, z and the cylindrical coordinates r, theta and z are given as x is equals to r cos theta, y is equals to r sin theta and z is equals to z. So whenever you want to convert Cartesian coordinates to cylindrical coordinates, you have to assume x as r cos theta, y as r sin theta and z as z. Okay. So the triple integral f of x, y, z dx, dy, dz will be equals to triple integral f of, put in place of x, r cos theta, in place of y, r sin theta and z will remain z into dx, dy, dz can be written as what? Mod j dz dr d theta, right? Now our task is to find this Jacobian j. which will be given by del of x, y, z upon del of r, theta and z. So now this j can be written as determinant of del x upon del r, del x upon del theta, del x upon del z. Similarly, differentiate with respect to y. So del y upon del r, del y upon del theta, del y upon del z. And lastly, differentiate with respect to z. So what you will get? Del z upon del r, del z upon del theta and del z by del z. Now we have the values of x, y and z as this, right? So differentiate all these three with respect to r, theta and z and solve this determinant. So what you will get your j as r, right? Now substitute this value of Jacobian in this equation, right? So on substituting, this will become r dz dr d theta, right? So now let us begin with examples. So we have to evaluate triple integration from 0 to 1, 0 to square root z, 0 to 2 pi r square cos square theta plus z square r d theta dr dz. Okay. So now let us start with the solution. So this is your given question, right? So firstly, what we will do, we will assume our cos square theta is 1 plus cos 2 theta upon 2. Okay, and then we will integrate this firstly with respect to what? Theta, right? So what will keep constant? R and Z is constant, right? So this integration 0 to 1, 0 to square root z, r dr dz will remain as constant. Okay. So now let us start the integration with respect to theta, right? So keep this r outside. Now r square by 2, that is constant, so keep as it is. Now integration of 1 will be theta. Integration of cos 2 theta will be what? Sin 2 theta upon 2. Now this z square is constant, so keep it as it is. And integration of 1 d theta will be what? Theta. And your limits are 0 to 2 pi, right? So now let us put the limits in place of theta, right? Now here you have theta, right? And here too you have theta. So you can keep 2 pi outside. What will remain? Integration 0 to 1, 0 to square root z. Now multiply these two. So you will get r cube upon 2. Now suppose if you put 2 pi here, then you will get sine 4 pi, which give us answer as 0, right? So this term is gone. Now here what will remain? Z square into this r. So z square r dr dz. Okay. Now you have to integrate this term with respect to r, keeping what constant? Z as constant, right? So now let us start the integration. So 2 pi integration 0 to 1 dz will remain as it is. Now integrate this term. So you will get r is to 4 upon 8 plus. Now z square is constant, so keep it as it is. Integration of r will be what? R square by 2. And your limits are 0 to root z, right? Now let us put the limits first. So 2 pi and integration 0 to 1 dz will remain as it is. If you put root z, what you will get? Z square upon 8 plus z cube by 2, right? Now if you put 0, the whole term will go to 0, okay? Now our last step is remaining, that is we have to integrate this term with respect to z, right? So on integrating you will get 2 pi times z cube upon 24 plus z raised to 4 upon 8 and your limits are 0 to 1. Okay. So now let us put the limits. So what you will get? 2 pi times. If you put 1, you will get 1 upon 24 plus 1 upon 8. And if you put 0, the lower limit will become 0, right? So now on simplification, you will get your answer of the triple integral as what? Pi by 3. Okay. So now let us solve one more example. Here we have to evaluate triple integral over r square root of x square plus y square dv, where r is a solid bounded by the surfaces x square plus y square is equals to z square, z is equals to 0 and z is equals to 1. So this is a cylinder and it is bounded by the planes z is equals to 0 and z is equals to 1. Okay, so now let us start with the solution. So here we will evaluate this using cylindrical coordinates r, theta and z. So what we will assume, x as r cos theta, y as r sin theta and z as z. Therefore from this what we can say, x square plus y square is equals to r square, right? Because x is equals to r cos theta and y is equals to r sin theta. Therefore your x square plus y square will be what? R square, right? Therefore square root of x square plus y square will be r. And your dv, that is dx, dy, dz will be equals to mod j times dz, dr, d theta. But for cylindrical coordinates, our Jacobian is what? R. So dx, dy, dz will be equals to what? R, dz, dr, d theta. Okay. So now let us find the limits. Now from this what we can say, that square root of x square plus y square will be less or equals to z, right? Now z is less or equals to 1, right? So from this and this what we can say, that our limits of z is from r to 1. Okay. Now our region is bounded by the cylinder and these two planes. So it will be a circle, right? Of radius r, that is x square plus y square is equals to r square. Therefore z square is equals to r square, right? Therefore we can say z is equals to r, right? Now we are given two limits of that is 0 and 1. So from this we can say that r is equals to 0 and r is equals to what? 1. So this is a unit circle, right, of radius 1. So our limits of r will be from what? 0 to 1. Right, and the limits of theta will be what? 0 to 2 pi. Okay, so now let us put the limits, and this, that is square root of x square plus y square is equals to r. Okay, so your triple integral will become triple integral over r. This will become your r, and dx, dy, dz will be equals to what? R, dz, dr, d theta, right? Now this will become r square, and put your limits. So they are 0 to 2 pi, 0 to 1, r to 1. Okay, so firstly we will integrate this with respect to z, keeping r and theta as what? Constant, right? So your integration will be z from r to 1, right? Now let us put the limits. So what will we get? R square times 1 minus r dr d theta. Okay. So if we simplify this, what will we get? R square minus r cube dr d theta. Now let us integrate this with respect to r. So integration will be r cube by 3 minus r raised to 4 upon 4 from 0 to 1 d theta, right? Now suppose if we put the limits, firstly we will put 1. So what will we get? 1 by 3 minus 1 upon 4. And if we put 0, the whole term will go to 0. Now simplify this. So what will get outside? 1 upon 12. And what will remain? Integration 0 to 2 pi d theta, right? Now integration 1 d theta will be equals to theta, and the limits are 0 to 2 pi. Finally put the limits. So you will get your answer as what? Pi by 6, right? Now let's go to our next topic, that is triple integrals in spherical coordinates, right? Spherical coordinates r, theta and phi are used to evaluate the integral in the regions which are bounded by the sphere with center at the origin. Okay, so the relations between Cartesian coordinates x, y, z and the spherical coordinates r, theta and phi are given as x is equals to r sin theta cos phi, y is equals to r sin theta sin phi, and z is equals to what? R cos theta. Okay, so we will substitute this in our triple integral, which is given by triple integral f of x, y, z dx, dy, dz. Replace this x by what? R sin theta cos phi, y by what? R sin theta sin phi, and this z by R cos theta. Dx, dy, dz will be equals to what? Mod j dr, d theta, d phi. Now our task is to find this Jacobian j. So j is given by del of x, y, z upon del of r, theta and phi. So this can be written as determinant of del x upon del r, del x upon del theta, del x upon del phi. Similarly, we will find partial differentiation of y with respect to r, theta and phi. So del y by del r, del y by del theta, del y by del phi. Okay. And lastly, with respect to z, so del z by del r, del z by del theta, del z by del phi, right? Now on finding the partial differentiation and evaluating the determinant, we will get our Jacobian j as what? R square sin theta, right? Now we will put this value in our Jacobian j, right? So our dx, dy, dz will be written as r square sin theta, dr, d theta, d phi. Okay, so this will be the change whenever you convert into spherical coordinates, right? So now let us start with the example. So we have to evaluate triple integration from 0 to infinity dx, dy, dz upon 1 plus x square plus y square plus z square whole square. Okay, so now let us start with the solution, right? Now, looking at the integral, it is difficult to integrate this in Cartesian form, right? So what we will do? We will put x as r sin theta cos phi, y as r sin theta sin phi, and z as r cos theta, and evaluate this integral into spherical form. So now, the region of the integration will be in the positive octant of the plane. Why we are saying this? Because our limits are from 0 to infinity. So this octant will be a positive octant, right? So now the limits of r will be what? 0 to infinity. Okay. Then the limits of theta will be what? 0 to pi by 2. And the limits of phi will be 0 to pi by 2. We have these limits because our region of integration is only our first octant, right? So now, the spherical form of our given integral will be triple integration. Put the limit of r first, 0 to infinity. Then put the limit of theta, that is 0 to pi by 2. And lastly, put the limit of phi, that is 0 to pi by 2 again, right? Now we will replace dx, dy, dz by what? Mod j times dr, d theta, d phi, right? But our mod j is what? R square sin theta. So we have replaced this by r square sin theta, dr, d theta, d phi, right? Now on replacing x, y and z by our spherical coordinates, we will get as 1 plus r square whole square. Okay? Now let us separate these terms. That is, firstly we will keep r terms, then theta terms, and then phi terms, right? Now firstly let us assume r as tan t to evaluate this integral, right? Therefore dr will be what? Sec square t dt, right? Now we will bring a change in the limits also. Now we are given r as 0, right? So put r as 0. So you will get 0 is equals to what? Tan t. So your t will be what? Tan inverse 0. So you will get your limit as t is equals to 0. Now suppose if you put r as infinity, right? So you will get infinity as what? Tan t, right? So t will be what? Tan inverse infinity, which will give us t as what? Pi by 2, right? So your limits of r converted to t are 0 to pi by 2. Okay, so now our integral will become 0 to pi by 2. Put r as tan t. So you will get tan square t upon, here in the denominator you will get 1 plus tan square t whole square. So this will be written as sec raised to 4t. Now your dr is what? Sec square t dt, right? Keep these two terms as it is. Now this sec square will get cancelled out, right? So what will remain finally? Tan square t upon sec square t, right? Now convert this into sine cos form. So what will remain lastly? Integration 0 to pi by 2 sine square t. On integrating this term, we will get minus cos theta and the limits are 0 to pi by 2. Integration of this term will be 5 and the limits are 0 to pi by 2, right? Now we'll replace the sin square t by what? 1 minus cos 2t upon 2. Now put the limits over here. So you will get minus cos pi by 2 plus cos 0. And suppose if you put limits over here too, you will get answer as what? Pi by 2. Right? Now we'll start integration of this term keeping 1 upon 2 outside. So the integration of 1 will be t minus integration of cos 2t will be sin 2t upon 2 and your limits are 0 to pi by 2. Now we know cos pi by 2 is 0. So this term is gone and cos 0 is 1, right? So 1 into pi by 2, only pi by 2 will remain, right? So now this 1 by 2 will remain as it is. This pi by 2 will remain as it is. Put the limits over here. So if you put pi by 2, you will get pi by 2 minus sin pi upon 2. But the value of sin pi is what? 0, right? So only pi by 2 will remain. Suppose if you put 0, then the whole term will go to 0, right? Now simplify this. So what you will get your answer as pi square by 8. Okay, so I hope you have understood throughout the session. Thank you for watching.